Okay, good afternoon slash evening slash morning to all of our viewers today. Welcome to our first Akka.net community stand-up for 2024. So we're off to a fast start here. We've actually done a whole bunch of pretty important changes to Akka.net Core that have all shipped as of last night. So Akka.net 1.515 rolled out. So I guess we'll go ahead and talk about Akka.Analyzers in a bit more depth towards the end of our meeting today. So why don't we go ahead and just jump right in and talk a little bit about some of our recent releases here. We've released pretty significant updates to both Akka.net and Akka Hosting that have both shipped. I guess, Gregorius, I'm going to have you start with these two. Actually, you know what? We have an Akka.net upgrade advisory for 1.515. I forgot that I spent some time writing this yesterday. Let me go and grab that. Yep. What's new in 1.515? I guess before we talk about cluster client, let's talk a bit about standardizing our dependencies on Microsoft.extensions and everything. So this is something that you worked on, Gregorius. Do you want to take us through that real quick? What's the sort of bottom line on this change here?
Yeah. Akka.net does a dual build to .NET Standard 2.0 and .NET 6.0. The problem is that if we upgrade all of our dependencies to the latest, all of our Microsoft extension to the latest, they sometimes broke backward compatibility, and they stop supporting anything below, like, let's say if they ship out 8.0.0 version, they might stop backward compatibility for .NET 6 or .NET 7, which we don't want to happen in our project. So what we did is that we changed the dependency to a range version instead. So everything from 6 and up should be fine.
Yeah, let me just grab that real fast. I think it's in is it in the props file? Is that where we did that? Yeah. So basically, I think before we were supporting everything from .NET 5 onward, and now I think what we're going to do going forward is we're going to support 2 LTS releases back going forward. So we're going to support .NET 6 and later. So .NET 6 is getting, I think, deprecated. It's either already been deprecated or it's about to. I can't totally remember, but I figure this is a big enough up window for people who are on .NET Core and are actually using these libraries, the Microsoft.extensions.di, hosting, config, all that stuff. This is a big enough window where this should capture the cohort of people that are out there. I mean, dude, if you're still running on .NET Core 3.1 or .NET 5, you've got bigger problems. But this should basically be able to capture that. So we standardize that. And then in the upgrade advisories, I kind of touched on your changes here, Gregorius, which is that a couple of users discovered that the Akka.Cluster client wasn't able to serialize their own message types appropriately. And Gregorius, you investigated that, and what did you find?
Well, it turns out that there are a couple of messages like send to all and publish that are duplicated between cluster client and the PubSub project, and the one that are sent using the cluster client code wasn't being serialized properly. So we did a fix there to make sure that it does use the correct serializer, but you have to set it up inside your configuration to do that.
Yeah, so in order to make sure we didn't break behavioral compatibility, we kind of funnily enough, we basically left this bug intact. We have the ability to fix the bug by just changing your config here. And the reason why we did it this way is so we maintained wire format compatibility. Like if your code was working properly and you never ran into any problems, then like, okay. Well, we don't want to introduce one by changing this on the fly. But if your code was running into these serialization issues that are documented on this issue here, 6803, you just need to go ahead and change this setting. And Akka.net 1.6, we'll go ahead and change this setting to off by default. So that way all the correct serialization will be used going forward. But for a revision release like 1.515, it's not cool to go ahead and rug pull people on that note. So that's another
Hmm.
change that Gregorius made. Um,
Yeah, I guess it really makes a difference if you're doing a rolling update because everything has to be able to talk to everything while you're doing an update. And afterward, you can actually set it to on.
Yeah, yeah, absolutely. Next big change I want to talk about are the cluster sharding improvements that we made. So actually, I mentioned this in our release notes as well. So we did a couple of big things with cluster sharding in this release. The first thing we did is these old delegates. I'll go ahead and pull these up real quick. The extract entity ID and the extract shard ID. Delegates absolutely suck for building extensible APIs down the road, and the reason is that you can't extend a delegate. You have to replace it with a totally new delegate type. So one of the inefficiencies that I had found when I was doing some work on cluster sharding like last summer is that we end up having to perform a lot of duplicative work inside the actual sharding actors for trying to figure out the shard ID. And so I have an issue where we kind of documented some of the proposed design changes. I think that's might be this one. Let me just double check. Let's see. 6717. There we go. Where we kind of documented some of this stuff. And I mentioned it somewhere, but the basic problem is that we should be able to go ahead and we compute the entity ID from the content of the message. And that's like kind of how sharding works by default. But the way the infrastructure was designed internally is that we use the entity ID to compute the shard ID. That's basically how sharding works. But none of the APIs were designed to actually do that. So they require us to constantly pass in the message over and over and over again. And this results in a lot of duplicate work, which actually noticeably impacts the throughput of the sharding system. Um, the other thing we wanted to do was I thought it was pretty smelly that, let's see if I find this here. This is like some example code from the actual Scala API. But you'll notice here that this is a class that is built into the original Scala Akka. And what it does is it wraps the message extractor written by an end user and identifies automatically handled messages that are basically sent to the sharding system from other Akka.NET components, such as the sharding envelope, which, by the way, you can use yourself, and also the shard region.start entity message, which is what we need for remember entities. I always thought it was pretty nasty that users had to manually handle these messages themselves. That kind of felt like a leaky abstraction to me. So in Akka.NET 1.515, we now handle this for you automatically on one condition. The condition is that you stop using these delegates, the extract shard ID and the extract entity ID. We rewrote the internals of Akka.Cluster.Sharding to only use the iMessage extractor interface instead, because that message extractor interface now supports a new member which will allow you to go ahead and compute the shard ID from the entity ID directly, which solves that performance problem we had before. If we go and we take a look at the numbers here, I haven't had a chance to rerun these on .NET 8. So these numbers are still on .NET 7, I believe. Yeah, here they are. So you'll see that our baseline numbers for doing, let's say, using cluster sharding with single request response takes us about 5.5 microseconds to go ahead and route a, let's see, I don't remember what the exact number of messages are here. I think it's like 100,000. But basically it takes about, yeah, 5.5 microseconds to do that. In the older versions of Akka.NET. And then if we're going over the network, the latencies obviously get a bit higher. Well, with Akka.NET 1.55, we're able to shave off about, let's say, 5 to 8% throughput by just making the sort of duplicative calculation, by eliminating this duplicate calculation going forward. So the whole system has gotten basically about 5 to 8% faster than it was before, just by not constantly needing to pass in the same message over and over again. And this performance improvement might even be potentially better in the final finished product than it was here when I took it. So strongly encourage everyone to go ahead and upgrade and take advantage of this. And the other thing I want to kind of use as a bit of a dovetail into our future Akka.NET plans and our community stand-up here is one of the things that I did to help support this code change that we made in 6863 is we introduced Akka.Analyzers and we introduced a code fix that will detect when you're handling either of these two message types that are automatically managed by Akka.net. We will detect that, flag it with a compiler warning, and then even use a code fix to go ahead and suggest here's how you can basically restructure your message extractor in order to improve your performance, is what it does. So essentially, it's able to help strip out duplicate work from happening inside your own application. And so I have a little demo to that effect that I'm going to pull up in just a moment here. Hopefully, it won't fail on me. But I have a little demo that I'll use to go ahead and demonstrate this. But for the time being, I'll go ahead and maybe do things out of order today and skip to our show and tell. And we'll use this as an opportunity to talk a little bit about Akka.Analyzers, our new project that we've included in Akka.net 1.515. All right, so Akka.Analyzers is a brand new project that we've created. It's now referenced by default in the core Akka NuGet package, which means that all you have to do to benefit from this is just upgrade to Akka.net 1.515. This transitive dependency will get pulled in by anything that uses the basically the Roslyn build chain. So that includes JetBrains Writer or Visual Studio or VS Code. Anything that uses that will go ahead and benefit from these analysis rules automatically, provided that you upgrade. So the Roslyn compiler platform has been around for about 10 years, I would say, maybe slightly less than 10 years, but not too far from it. It's the compiler platform for .NET. So one of the things that they did with Roslyn is they completely rewrote the compiler platform to all actually be implemented primarily in C# itself. So rather than it being a bunch of C++ code that kind of analyzed your syntax trees and everything else, it's actually all been written in managed code and maintained that way for quite a long time. Plus, Roslyn is all open source as well. What's really useful about the Roslyn compiler platform is that it's open to extension by third-party developers like us. And there's 3 different ways it lets you do that. Source generators is something that you saw a demo of from Gregorius back in maybe September or August, maybe. That was when he was previewing how we're looking at doing serialization in Akka.NET 1.6. So source generators give you the ability to do compile time code gen. But the 2 areas that we're going to be talking about today are these 2, analyzers and code fixes. Analyzers basically allow you to tap into Roslyn's solution analysis platform and flag additional, let's say, compiler warnings or errors that aren't raised by the normal, let's say, default C# rule set. Then on top of that, you can also provide what's called a code fix via Roslyn, which is a suggestion on how to go about fixing a problem one of your analyzers might have detected. So we're basically shipping a combination of analyzers and code fixes inside Akka.Analyzers. Now, these code fixes and analyzers can be distributed either as a NuGet package, which is what we've done, or they can be distributed as a Visual Studio extension. We opted to go the NuGet route. That way, all of them could get consumed transitively via any users of Akka.net going forward. So the goals of the project, we've got 2 really big goals. I think 2 really big goals of the project. The first big one is preventing footguns. Now, every framework is going to have things that users can do that can potentially inflict self-harm. XUnit, ASP.NET, SignalR, you name it. Akka.NET's no different in that regard. But one of the things we want to do, and we kind of used XUnit as our sort of example for this, is XUnit actually has been shipping a set of analyzer tools for several years now that are used to kind of help analyze the quality of people's tests and tell them like, yeah, this test won't run because this class doesn't have a public constructor, so it can't get discovered, or you're using a deprecated assertion method, you should be using this one instead. And that kind of helps make sure that when XUnit introduces changes in how the library is done, or if they get common bug reports from many users, they can go ahead and kind of codify all that knowledge into an analysis rule plus a code fix suggestion and help basically reduce the total amount of like support traffic that actually ends up arriving on their GitHub issue tracker. So when we know the user's doing something harmful, we can go ahead and add a custom compiler warning. We can also add compiler warnings when we know the user's doing something that's non-performant. So if it's not, let's say, harmful, like good example, an example of a user doing harm is like creating a situation that's going to deadlock. If we can go ahead and detect that, we need to flag it as an error and just say, no, like you need to change this. But if the user is doing something that's merely inefficient, we can go ahead and add a warning. That's an analyzer rule around detecting when users are trying to handle messages that are already handled automatically by Akka.net. That's a good example of, let's say, a performance warning that we might include. The other really big benefit, and this is kind of part of a bigger strategy for Petabridge and for Akka.net, is being able to use Roslyn analyzers to nudge users towards upgrading to newer abstractions and newer APIs. This is designed to facilitate helping users upgrade from one set of older APIs to another. And what this will allow us to do is that provided that users start adopting versions of Akka.net that have these code fixes and these analyzers built into them, this will allow us to start getting more aggressive with changing the API surface area and future releases. So if we want to start doing things like, for instance, changing the way serialization works or changing the way networking works or whatever, taking advantage of Roslyn analyzers and code fixes will make it a lot easier for us to go ahead and safely introduce those to the user base, because now we have a compile time validated sort of, let's say, set of code fixes that can be applied automatically without the user needing to assess the risk for themselves and come up with their own fixes and then test it. No, instead we basically can have a repeatable, sort of reliable solution for doing this. We're just leveraging static analysis is all that we're doing. So on that note, I've got a couple of little demos for us that I'm going to bring up here. If I can go ahead and grab those. I have a little pull request on, this is our Akka.net code samples repo. This is what we use for talking a bit about like Akka streams.Kafka integration and also working with cluster sharding. So I've got a little demo right here where I've introduced a couple of bugs into my solution. Let me go ahead and grab this up in Writer here. Let's see. So I think I have everything up and running currently. Let's see. Let me pull this up in the web browser here. All right. So I've got a couple of products. This is all using Akka.Cluster.Sharding under the covers. If I do, let's see, PBM cluster sharding regions. Helps if I spell sharding right. Regions. There we go. Got one region there, and I do region stats, our products. I can see that we've got 2 shards, 2 entities. All right, looks good so far. Go ahead and create another new product here. We'll do Weller Foolproof. Say it's $99. Do 1,000 of those. Submit. All right, now we got 3 products on our list here. If I go to our home screen, I'll go and run this query again. And now we're up to 3 shards, 3 entities. Okay, cool. Got it. Let's take a look at what's going on inside our solution. I'm going to go and shut the sample down real quick. Now, I am not currently running Akka.net 1.515. I think I'm running 1.57 in the solution right now. So we're a few versions behind. This is our message extractor, and you'll see that I've been manually handling, remember, entities in here. That's something that you needed to do in Akka.net 1.514 and earlier, especially if you're using the delegate types, by the way. You absolutely had to do that. And then to boot, I've taken my product totals actor. This is my entity actor right here. And I've introduced a bug. This bug that I have introduced is using pipe2 and passing in the sender property directly from the actor class. Now, we did do some work to try to basically make it so this actually won't produce an error. We did some work around how we restructured pipe2 kind of like late in the Akka.net 1.4 lifecycle to try to help prevent some of this. But that being said, it's not perfect. So one of the things that can happen here is that sender is actually a mutable field. This actor's value can change. Potentially as it receives different newer messages. So that's what's kind of going on behind the scenes here. So these are both examples of things that should get flagged by some of our compiler rules in Akka analysis. If I go and actually pull up our website, we actually have a list of all of our analysis rules here. We have 4 that we ship with right now. We've got one that basically says don't new up new actors. Another one that says you should always close over the sender when you're using pipe2. And then we have a couple of API usage ones like this Akka.Cluster.Sharding issue right here. So one thing I'm going to do is I'm going to pull up my command line and I'm going to do git stash apply. This is going to upgrade the version of Akka.net I'm using to 1.515 inside our directory build.props file. And if I go back here, we'll see that Ryder is recomputing the solution and analyzing things. And lo and behold, we'll see this compiler warning show up where there wasn't one before. All I had to do is upgrade the version of Akka.NET that I'm using. You'll see down here, you'll see a warning that says, when using any implementation of a message extractor, you should not use messages that are automatically handled by Akka.NET, such as shard, start entity, and sharding envelope. And if I click on this link right here, this will actually take us to the Akka.NET website, where we have a more in-depth explanation of what this rule does, along with links to the other affected parts of the API. And it even shows you a preview of what our code fix is going to do. So let me go back to our solution here, and I'll go ahead and hit Alt-Enter, and it'll simply delete the handler that we didn't need before. Is my example application on GitHub? Yes, it is. I'll go ahead and include a link to it right now. I'll go ahead and drop a link to this in chat so you all can get access to it. And there we go. There's the full example there. You don't need the pull request I'm working on, but this example is up on GitHub. It's in the Petabridge Akka.NET Code Samples repository. I believe this repo is actually pinned inside the Petabridge organization, so you should be able to find it there. So, okay, so we fixed that issue. Let me go ahead and try recompiling our solution. And you'll see down here, I can already see a build error showing up. And it's AK 1001. This is coming from the Akka.Analyzer solution. When using pipe 2, you must always close over sender to ensure the actor sender property is captured at the time you're scheduling the pipe 2, as this value may change asynchronously. So we try to explain what the error is here. Let's go and click on it. And you can see, yes, indeed, this is a compiler warning that's being flagged. Sorry, this is actually a compiler error that's being flagged. Now, you have the ability to use the pragma keyword to disable that inspection if you really want to, just like how you could any normal, let's say, sort of compiler warning. But the better thing to do here is to do Alt-Enter, and you can see a helpful suggestion. This is from the code fix provider that we've written for Akka analysis. And what this will do is it'll substitute that sender property for this one up here. I can go ahead and get rid of that. All right, let's go ahead and try rerunning our solution now and see if everything works. That'd be useful to see, wouldn't it? All right, so we got our web application going. And then let me launch my backend app here. All right, I can see messages going through to the sharding actors, so that's promising. So let me go ahead and reload. All right, looks like that's going pretty well. I can go ahead and read and write to this entity. So yeah, looks like everything appears to have worked. Remember, entities worked on its own, and so did, and also, my little pipe 2 fix appears to have worked as well. So all of those code analysis suggestions that we're providing here, I'm going to talk a little bit about how the sausage is made, just because this is something new I had to learn, and I learned a lot from analyzing how the XUnit project did it. This is the Akka.Analyzers repository. This is all open source. It's I contributed this to the I contributed this back into the Akka.NET organization, and it's open. And one of the reasons why I'm bringing this up is we actually need your help. All the people who are watching this live or are going to watch the recording later, we actually need your help coming up with good rule ideas that we should be adding to the tool set here. And one of the things that we've done to try to basically make sure we're delivering sort of professional quality around these analysis rules to the end users is we have followed some of the best practices that like XUnit and others like the Microsoft themselves use for being able to make sure that all of our code fixes and our analyzers are exhaustively integration tested. So if I go, for instance, to my must not handle automatically handle messages and message extractor analysis specs. So it's a bit of a mouthful. If I go down here, you can see I've got a whole bunch of theories for for success cases. This means these are examples that shouldn't trigger the rule. And then we have a whole bunch of theories with failure cases, which also indicate the exact line where the exact line and syntax where the error is. And we go ahead and run them all through. If I scroll down here, this little verification testing tool that's provided by the Roslyn compiler platform. So all of our analyzers go through pretty extensive integration testing. And if I go here and I take a look at our code fixes, We also do snapshot testing for our code fixes themselves as well, where I take sort of a before and I take an after and a sort of character by character comparison, including the white space. I can't begin to tell you how much time I spent troubleshooting, dealing with the formatter in Roslyn to make sure that if we are removing or rewriting an if statement, um, to get rid of a problematic clause, I've got to make sure that everything still gets indented the right way afterwards. I spent a lot of time messing around with that. But it's all working pretty good. We've got a pretty good framework in place now for being able to test and reuse all these different little, let's say, Akka.net constructs. And so I only just bring this up to kind of show you we're doing real, professional grade engineering work to try to make sure that all the analysis suggestions we're handing out and the code fixes are all robustly tested. I'm just trying to sell you on that. Where we need your help, if I go to issues here, we are very interested in trying to get more suggestions for rules that meet our goals. We're looking for either identifying, let's say, bugs that can be detected at compile time that we know are going to result in problems down the road, or we're looking at bugs that can go or suggestions to help move users onto more modern APIs. So I've got a good example of one of each of these. So this suggestion down here, we have the I with timers interface, which has been around for a few years. We should go ahead and analyze users' actors and see where they're using the context.system.scheduler directly. If they are using this API, we should suggest rewriting it to use I with timers. This will help us ensure that scheduled activities don't get leaked after actors shut down. That's the whole benefit of using this API over the older one. So we can go ahead and introduce some code fix tools and some analysis rules to detect that and fix them. That's an example of helping users be more productive by moving them onto a newer API. Alternatively, this was a rule actually suggested to me by one of our own customers, and I think it's because he'd been bitten by this. This is an example of something we could definitely detect at compile time that would result in a deadlock. If you have a receive async statement and you're trying to graceful stop yourself, this will never ever complete because while this actor is waiting on this task, the poison pill that is sent by graceful stop will never get a chance to be processed. As a result of this will go ahead and result in this actor not only not being able to gracefully shut itself down, but also won't be able to process any other messages while this happens. On top of that, if the actor did successfully shut itself down, this task would never complete anyway inside this receive async because the actor would be terminated. So it's just kind of like an example of an edge case that's just not resolvable. So my plea to you as an Akka.net end user, it doesn't matter how weird of an edge case your, let's say, if you've been bitten by a weird bug before where you just know it doesn't work and it's something that you think we can detect at compile time, there's some issues we definitely cannot detect at compile time. Good example is inspecting the value of a variable. Can't do that at compile time. That's got to be a runtime issue. But being able to go ahead and identify syntax errors that are going to result in programs that are illegal or programs that aren't executing optimally, those are exactly the sort of use cases that the Roslyn platform is built for. And we would love your help suggesting some rules and issues we can go and implement. So right now, we only have those 4 that are implemented. Gregorius and I have a goal of getting, I think, 10 rules implemented with 5 code fixes by the end of the quarter. Is that right, Gregorius?
Yep.
Yeah, so we've got at least another 6 to go before the end of the quarter, and we're going to begin introducing additional changes into this package down the stretch. So I would strongly encourage you all to go ahead and upgrade to Akka.net 1.515 so you can start transitively getting these rules pulled in. And if you have an idea, no matter how far afield it seems for an Akka.Analyzer rule, go ahead and suggest it on the issue tracker for Akka.Analyzers here. I'll drop a link to this in chat as well. This will help us discover what are some of the problems end users have run into and what can we do to fix it. And we're very keen on doing that. So by any stretch of the imagination, please go ahead and let us know what we can do to help you. We would appreciate that very, very much. And I'll go ahead and show that URL on screen. So I guess that's all that I've got for today. Gregorius, this is kind of, you've been heads down working on a whole bunch of other Akka.net issues for users. So this might be your first time seeing Akka.Analyzers.
Yep, it is.
What feedback, what's your spit take on that?
It's really cool. But from my experience working with the code generator, I can see that it's a pain to actually code.
Writing an analyzer rule from scratch is definitely a pain. And, I'll give you guys my pro tip for that. I always ask ChatGPT to go ahead and start one for me. And then I end up having to go and tweak it and fix it later. Um, but that way, doing all of the like syntax node analysis and all of the really like low level compiler API stuff, that way I'm not starting from scratch every single time. And I think that's what's helped me because I only started this project a few weeks ago. So I was kind of working on it like during the lull around Christmas. So I think that actually helped me be pretty productive with it. There are a couple things ChatGPT does that are not good patterns for Roslyn. Good examples, they do a lot of lexical equality versus symbolic equality, which is like basically they'll go ahead and look at the text of an API versus figuring out if that method belongs to this symbol, which is lexical equality is very poor. You want to use symbolic equality. Question for Christopher Rowe. Will this provide feedback for F# code too? So all the analyzers we've written so far have all been targeted at C#. It should be possible to contribute F# ones as well. I'm not wholly certain basically how well the compiler platform can handle that. But I know, for instance, if I take a look at the source down here, if I go to Akka.Analyzers and I take a look at this guy, I wonder if I can do, let's see, language names. Yeah, so in theory, it looks like the compiler platform should be able to support F#. But I think it would just be need to go ahead and ship as its own distinct analyzer. This one is programmed to work against C#. If there's any VB.NET developers out there, God help us, I would need to ship another one for them. And then F# would need its own as well. But it is within the realm of theoretically possible, as far as I understand, but not something that I have personally delved into. But yes, you're right, Gregorius. Writing the analyzer rules is a pain. That's why I recommend starting with ChatGPT. I honestly have been doing like test-driven development with this stuff, where it's like I have this code, and here's the problem I want to identify with it. Help me write a rule that will detect this, and then I'll do the same thing for the code fix as well. And that and writing shell scripts have been my two favorite uses for ChatGPT so far. So yeah. All right. Well, thank you very much for sticking with us today, everybody. We really appreciate your continued support of the Akka.net project, and we look forward to shipping some more rules and some more updates. If you have any suggestions, you can leave it for us on the GitHub issue tracker, or maybe you can mention them in Discord if you want to go ahead and float some ideas around. But otherwise, thank you very much for your time today, and we'll go ahead and catch you next time. All right. See you in February. Bye-bye, everybody.